So, hello guys, hope you are doing well. So, we are again here with the topic Start Data Conversion. So, this is our lecture number 6 in the series of Basic Electrical Engineering. My aim is to provide you the topics with minimum time, okay, and especially for university exams, okay. So, today's topic is star delta conversions. Star means it looks like star, it's star type. Simply from that it's a star connection, and delta connection it's look like delta, so it's a delta connection. Okay, that's it here. So now we have one star connected network and we have one delta connected network. We'll convert from star to delta, delta to star. So let's check. Suppose we have given this delta connection. Now we want to convert this into star. Okay, first see this one. Suppose we have given one star, one delta connected network, and we want to convert it to a delta network, a star network. Okay, these conversions we normally do to simplify the networks. Okay, nothing uh, much important than that. We have for simplification, for simple design, we do this one. So first thing is a delta connected network is given. We want to convert it into a star. Okay, x y z, here x y z, we'll keep this x y z node as same. Okay, these 3 points will keep same, will not change those values, but we have to change the value of this R1, R2, R3 and RA, RB, RC registers value. Okay. So first thing, delta is given. We have to draw this star connection. That means we need to calculate the values of RA, RB, RC when we know the value of R1, R2 and R3. Okay. For RA, what we have to do? We want to draw this star from this delta. So let's imagine this star inside this delta. So RA will be here, here will be RA, here will be RB, here will be RC. Okay. Now we want to calculate this value of RA. Now check with this RA which two resistor value is connected, or which two branch is connected. This R1 resistor, okay, and this R2 resistor. This R1 and R2, these two are connected with RA. When we place this star inside the delta, but our aim is from this delta to star. Okay, so we'll put this star, we'll imagine this star inside this delta. Now for calculating RA, check which two branches are connected to this RA. RA is connected here, so R1 and R2, these two are connected with RA. I am repeating this thing because if you understand only the RA, you don't need to understand RB and RC. You can directly just write. Okay, so just understand RA. RA is placed here, so nearby two branches are connected with this RA. Branches are R1 and R2. Okay, so we'll write R1 into R2 by R1 plus R2 plus R3. Okay, this is the value of RA. So we'll get the value of RA and we can simply write the value of RA here from this delta connected network. Okay, what is the logic? We'll imagine this star inside this delta. Then we'll see the nearby branches of RA or connected branches with RA are R1 and R2. So we'll write R1 into R2 by R1 plus R2 plus R3. Okay. For RB, for RA, RB, RC, at the downside R1 plus R2 plus R3. Same, okay. R1 plus R2 plus R3. Now for RB, we have imagined this RB star connected network here. So nearby RB, two branches are these two, this one and this one, R2 and R3. So R2 into R3. Downside is same, R1 plus R2 plus R3. Then RC. RC we have imagined here. So connected with RC, these two branches. This R1 and R3. So R1 and R3. So very simple logic. Okay. Just imagine this star inside this delta. So we'll get the delta values, star values from the delta. Okay. What is the logic? R1, RA, RB or RC. What about the value you want to calculate? Just check near, suppose for RC, just check which two branches are connected to this RC or which two are the nearby. Okay. And for RC, R1 and R3. So R1 into R3, R1 into R3 divided by total all resistors. Okay, R1, R2, R3. Okay, that's it. So now we'll calculate the value of R1, R2 and R3. That means, I'll just remove this one, okay. That means we have given one star connected network. Okay, we have given one star connected network. This RA, RB, RC are known to us. Now we don't want to change the location of X, Y, Z, but we want to calculate or we want to get a circuit that is delta connected. Okay, so X, Y, Z, it will not change, only the values of resistor will change. We have to calculate this R1, R2, R3. That means we have given one star connected network. We want to calculate the values of a delta connected network, R1, R2, R3. Okay. So same thing we will try to imagine or the delta network. If we want to draw the delta network, it will be like this. Okay. So X, Y, X and Z, between X and Z, which one? R1. So R1 will come here. Between X and Y, which resistor? R2. So R2 will be here. Between Z and Y, which resistor? R3. Z and Y. So we can write R3 resistor here. Now for all the values R1, R2, R3, it's same. RA into RB plus RB into RC plus RC into RA. Okay, this is same for all. Second, same RA, RB plus RB, RC plus RC, RA. For R3 also, RA, RB plus RB RC plus RC RA. Okay, upside is same for all three. Now suppose for R1 we have draw the R1. R1 is between X and Z. We have draw the R1 here. Okay, if we draw the R1, that delta connected network, that we want the values, we will imagine that one here without changing the this points X, Y and Z, these nodes. Okay, so for R1 we'll just check the opposite side. The opposite side of R1, which branch register, which branch or which register is connected. Okay, the opposite side for R1, you can tell me, for R1 opposite side is RB. Okay, for R1 is here, the opposite is, or you can say the which branch is not connected with R1. Okay, RA and RC is connected with R1. That's also one logic. Okay, so opposite of R1 is RB, or RB is not connected with R1. So we'll just write for R1 RB. Okay, that's it. We'll get the values. Now for R2. R2 is between X and Y. R2 is here. So opposite of R2 opposite RC is there, or which one is not connected with R2? RC. RB is connected here, RA is connected here with R2. So RC is not connected. For R2, we'll write RC. Okay. Now for R3, I think you have understood already. R3 is here, opposite is RA. R3 opposite is RA, or this RA is not connected with R3. Okay, so this will be RA. So this is very simple. I think you have understood properly. Okay, from star to delta to star and star to delta. This is okay. These are the values when we have a delta connection given. We want star. Then this is the equation. And this one, when we have star given, when we have star connected network given, but we want delta, then these are the equations. Okay. For university exams, you'll see the simply one common question. Like this. Suppose A, B and C, and there will be values will be given of this register. Maybe question is a very important and common question for university exams. Find R equivalent across, suppose C and B. Find R equivalent across C and B. This is important thing. Okay, when check here, the question is the R equivalent across which two point or which two node. Okay, this is very important. Suppose for this one solutions, how it will come? In university exams, you try to write every steps. Okay, you try to always write every steps properly. Suppose you can apply here this delta 2 star, this delta 2 star. Okay, whatever you are doing, you have to write. And this question here is CB. So at last, up to last, this your network will be like C will be constant, C and B. and this value, suppose if it is a x, you will not change that value until last. This will be x until last point, okay? And we'll get one upside, that will be all equivalent, okay? 1 2 3 4 5, this equivalence will come here, okay? This is, then we'll R C and B is equal to, it will be like this, it will come C F B. The best thing is, if you change this star, you can change to this star to delta, or you can change any one delta to star. If you change this star to delta, the best figure it will come like this. I don't know is it visible or not properly. This is A, B, C. It will come like this, okay? B and C. You will parallel here, you will parallel here, you will parallel here. Then one more network will come. Question is between C and B. So C and B will be there. Upside there will be like this. After that, it will come like this. Okay. A here. E. So if you have any doubt, you can simplify this also. Okay, but this is best logic to remember. You can put divide and put RA RB by RB. If you put, it will come RA plus RC. It will come like this. RA plus RC plus RC RA by RB. Okay, you can put like that also. So you can do motivations according to your, but this is best way to remember. So for today's class up to, that's it guys. If you have any questions, comment in the comment box, okay? I'll try to reply. So, and our lecture number 7 will be on source conversion, okay? Voltage source to current source and current source to voltage source. That is also important topic or important concept for network analysis, okay? Network theorems. So, I think you have understood the topic, start to delta conversion and delta to star conversion. So bye bye for now, enjoy your time.